KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Hello students, next question in integration exercise 7.5. This is the last question. Find integral 1 upon x into x square plus 1 dx. Okay. Here in denominator we have a linear factor and one irreducible quadratic factor. We have one linear non-repeated factor and one quadratic irreducible factor. So I will write 1 upon x into x square plus 1 as a upon x plus bx plus c upon x square plus 1. Okay, by taking LCM and cancelling denominator on both sides. So what we get? 1 is equal to a into x square plus 1 plus bx plus c into x. Okay. Now if we multiply inside, so ax square plus a, bx square plus cx. So overall x square common, so what will get? A plus b into x square plus cx plus a. Okay. Now to find out a value, b value and c value, by equating quotient of x square, quotient of x and constant term on both sides. So quotient of x square, left hand side 0, right hand side how much? A plus b. So a plus b equal to 0. Next, comparing quotient of x. This side what we have? C, no x term. So x quotient is 0, so c is equal to 0. Next, comparing constant, a is equal to 1. So a equal to 1, c equal to 0. Now as a plus b equal to 0, b is equal to what? Minus a. So minus a is nothing but minus 1. So a value is 1, b value is minus 1 and c value 0. Okay, substituting a, b, c values here. So what we get? 1 upon x into x square plus 1 is equal to 1 upon x plus minus x upon x square plus 1. Okay. Now integration of this part is nothing but integration of this part. Okay. Integral 1 upon x into x square plus 1 dx equal to integral 1 upon x dx. Okay. Plus integral minus x upon x square plus 1. I'll multiply and divide with 2. Multiply and divide with 2. So what we can write? Minus 1 by 2 into integral 2x upon x square plus 1 dx. What is the advantage is, now if you observe denominator x square plus 1, numerator is what? 2x dx. Okay. Now if you consider this as t, x square plus 1 as t, okay, 2x dx as dt. Now it is integral 1 by t dt. 1 by t dt is log mod t. So this part integration is log mod x square plus 1. Integral 1 by x dx is log mod x minus 1 by 2 into this part integration is log of x square plus 1. So final answer is log mod x minus 1 by 2 into log of x square plus 1 plus c. Okay. I will repeat once again. What is given in the question? Find integral 1 upon x into x square plus 1 dx. Okay. Denominator having one non-repeated linear factor and one quadratic irreducible factor, irreducible quadratic factor. So I will write 1 upon x into x square plus 1 as a upon x plus bx plus c upon x square plus 1. Okay. Now by taking LCM and cancelling denominator, what will get? A is equal to 1 is equal to a into x square plus 1 plus bx plus c into x. Okay. Multiplying what we get? Quotient of x square is ax square plus bx square. So a plus b into x square. Quotient of x is what? Cx. constant term is a. Okay. Now to find out a, b, c values, equating quotient of x square, equating quotient of x and constant term on both sides. So what will get equating quotient of x square? A plus b is equal to 0, that is one thing, and quotient of x, c this side 0, c equal to 0, constant term a 1, a equal to 1, c equal to 0 and b equal to how much? Minus a, nothing but minus 1. So substituting a, b, c values here, so what will get? 1 upon x into x square plus 1 is equal to 1 upon x plus minus x upon x square plus 1. So integral of this part is nothing but integral of this part. Okay. So that implies integral 1 upon x into x square plus 1 dx equal to integral 1 upon x dx plus integral minus x upon x square plus 1. Now here multiply and divide with 2. So what will get? Minus 1 by 2 into integral 2x upon x square plus 1 dx. Now what is the advantage is denominator if you consider as f of x, numerator is f dash of x dx. So integral of f dash of x upon f of x dx is log mod f of x. So this part integration is log of x square plus 1. So final answer what we get? Integral of 1 by x dx is log mod x. So log mod x minus 1 by 2 into log of x square plus 1 plus c. Okay. Now with this we completed problems on exercise 7.5. Okay. Partial fractions problems completed. Integration using partial fractions completed. Next concept is a very important concept, that is integration by parts. Integration by parts. Okay. Here we know that integral of f of x plus g of x is integral of f of x plus integral of g of x. Integral of f of x minus g of x is integral of f of x minus integral of g of x. What about integral of f of x into g of x? Integral of f of x into g of x. Integral of f of x into g of x, that is integration of product of two different types of functions. Integration of product of two different types of functions. But it is not like suppose you have integral x power 5, you write it as integral of x power 3 into x power 2. Okay. Integral of product of two different types of functions. What is the formula? We will discuss now. Okay. Now first of all, for integration by parts formula derivation, we can derive this one using differentiation of product of two functions. Using derivative of product of two functions. Okay. Now for this, if e, u and v are two differentiable functions of a single variable x. Okay. Means u is a function of x, differentiable function of x, and v is a differentiable function of x. Now we know this formula, derivative of u by v. Okay. Derivative of u by v equal to u into differentiation of v plus v into differentiation of u. Okay. Derivative of product of two functions equal to first function into derivative of second function plus second function into derivative of first function. Okay. This formula we know, every one of us know. Now integrating on both sides. This part integrating on both sides. So left hand side what we have? Integral of derivative of uv. Integral of derivative of uv is uv is equal to right hand side integral of u into dv by dx. Okay. This part integration, integral u into dv by dx integration, plus this part integration, that is integral of v into du by dx into dx. Okay. Now I will write this term this side. I will write this term this side. So what we get? Integral of u into dv by dx into dx is equal to uv minus of integral of v into du by dx into dx. Okay. Mark this one as 1. Okay. What we are doing, first of all, derivative of product of two functions, d by dx of uv is equal to u into dv by dx plus v into du by dx. Okay. Derivative of product of two functions is equal to first function into derivative of second function plus second function into derivative of first function. Okay. Now integrating on both sides. Integrating on both sides, what will get? Now integral of d by dx of uv. Okay. Integration and differentiation inverse process to another, what will get? uv. uv is equal to integral of u into dv by dx into dx. plus integral of v into du by dx into dx. Now using this, if I write this term this side, what will get? Integral u into dv by dx into dx is equal to uv minus of integral v into du by dx into dx. Okay. Now I'll consider u as some function f of x, u as some function f of x, and dv by dx as some function g of x, dv by dx as some function g of x. Now as dv by dx equal to g of x, by integrating on both sides, integral of dv by dx is v is equal to integral g of x dx. So left hand side is integral of f of x into g of x dx, integral of f of x into g of x dx is equal to, what is u? U is f of x into what is v? V is integral g of x dx minus integral of, what is v ma? V is integral g of x dx, integral g of x dx into du by dx. Du by dx means a derivative of this function, okay, nothing but f dash of x dx. If you write in proper order, integral of f of x into g of x dx equal to f of x into integral g of x dx minus integral of f dash of x into integral g of x dx whole dx. Okay. Now here what we are having, integral u into dv by dx into dx is equal to uv minus of integral v into du by dx into dx. Okay. Now let u of x equal to f of x, u I will consider as f of x and this function dv by dx as g of x. dv by dx equal to g of x, by integrating on both sides, v is equal to what we will get? Integral g of x dx. So from 1 what we can write, integral of f of x into g of x dx equal to u is f of x into v, v is what? Integral g of x dx minus integral of v, v is what? Integral g of x dx into du by dx, du by dx is what? Du by dx is f dash of x, f dash of x dx. Write in proper order, integral of f of x into g of x dx equal to f of x into integral of g of x dx minus integral of f dash of x into integral g of x dx whole dx. Okay, if you consider f of x as first function and g of x as second function, okay, then this formula may be stated as, how we can write, how we can tell is, integral of product of two functions is equal to first function into integral of second function minus integral of differential quotient of first function, means a derivative of first function into integral of second function. Integral of product of two functions is, formula is first function into integral of second function minus integral of derivative of first function into integral of second function. Okay, like this one, integral of uv dx means first function into second function dx is equal to, okay, integral of first function into second function is equal to first function into integral of second function minus integral of derivative of first function into integral of second function. The formula is very important. Integral of product of two functions, integral of product of two functions is, u we consider as first function, v second function. Okay, so integral of uv is equal to u into integral v, means first function into integral of second function minus integral of derivative of first function into integral of second function dx. Okay. Now here, while applying this formula, we have to take care of what we have to select as first function, what we have to select as second function. Okay. While applying the above rule, we have to take care, care has to be taken in selection of first function and second function. Okay, so I'll repeat once again formula. Integral uv is equal to u into integral v minus integral of derivative of u into integral of v. So integration of product of two functions equal to first function into integral of second function minus integral of derivative of first function into integral of second function. Okay, okay ma. Next, in product of two functions, integral of product of two functions, we have to be very careful in selection of first function and second function. Okay, now in product of two functions, if one of the function is not integrable, then what we will do is we will choose that function as a first function and remaining function as a second function. Okay, important points, these are in product of two functions, one of the function is not integrable. Not integrable means log mod x not integrable, directly not integrable, sin inverse x is directly not integrable, cos inverse x is directly not integrable, tan inverse x is directly not integrable. Okay, whenever you have these kind of functions, okay, which are not directly integrable, okay, then we will take that part as first function and remaining function we will take it as a second function. Okay, whenever we have product of two functions, integral of product of two functions, out of them one function is not integrable, such as log mod x, sin inverse x, cos inverse x, tan inverse x. In such case, we will take that part as first function and remaining function as the second function. Now, for example, in integral x into tan inverse x dx, here tan inverse x is not directly integrable function, so I will consider tan inverse x as the first function and x as the second function. Okay, in x into tan inverse x dx, but we know integration of x, but we do not know directly what is the integration of tan inverse x. So, we will consider tan inverse x as the first function and x as the second function. Okay, that is the first point. Okay, when you have product of two functions, out of them one is a directly integrable function, one is not directly integrable function. Okay, a function which is not integrable function, we will consider that function as first function and remaining part as second function. Okay, now second point, if there is no second function, only one function is given, okay, which is not directly integrable function, in such case we will take unity as the second function. Okay, if there is no second function, then unity is taken as the second function. Okay, now example, in integral of tan inverse x dx, this is not a directly integrable function. So, what we will do is the tan inverse x as first function u will consider and v will consider as 1. Okay, in integral tan inverse x dx, tan inverse x is taken as first function and 1 as the second function. Okay, now third point, if both the functions are integrable functions, if both the functions are directly integrable functions, then first function is chosen in such a way that derivative of the function has obtained under the integral sign is easily integrable. Means if both functions are directly integrable, then first function is chosen in such a way that the derivative of the function has obtained under the integral sign is easily integrable. Means when both the functions are integrable functions, you have to choose first function such a way that after differentiating, okay, whatever function we obtain, that has to be easily integrable function. It has to be easily integrable function. Okay. Now, usually we will use Eilert method to select first function. Usually following preference order for the first function. This is called eyelet method. Okay, eyelet means inverse function, inverse trigonometric function, logarithmic function, algebraic function, trigonometric function and exponential function. This rule is called eyelet rule. Means suppose in integration you have one inverse trigonometric function and one algebraic function. Okay, then we'll consider inverse function as a first function and algebraic function as a second function, like this. Now integral of x tan inverse x dx, you have one inverse trigonometric function and one algebraic function. So inverse trigonometric function as a first function and algebraic function as a second function. Okay, here integral x cos x, algebraic and trigonometric. So algebraic and trigonometric, algebraic is the first function and trigonometric is the second function. Okay, next one more example. Log x, here integral x e power x, algebraic and exponent. So algebraic is the first function and exponential is the second function. Okay, when both the functions are directly integrable functions, usually we will use this method for this order for first function. Suppose you have one inverse function and one algebraic function. Inverse function as first function and algebraic as second function. Suppose logarithmic and trigonometric. Logarithmic as first function and trigonometric as second function. Suppose algebraic and exponent. Algebraic as first function and algebraic function as first function and exponential function as second function. Okay, this method we will use. Okay, I will repeat. When you have product of two functions, if one of them is integrable, one of them is not directly integrable function, okay, whichever function is not integrable, we will take it as first function and remaining part as the second function. Okay, suppose only one function is given in the integration which is not a directly integrable function. In such case, we will consider unity, means 1 as the second function. Okay, when both the functions are directly integrable functions, then we will apply eyelet method to write first function and second function. Okay, now we will start the problems. First problem, example 17, find integral of x cos x dx. Okay, now here product of two functions, one is algebraic function and one is a trigonometric function. Okay, now both are integrable functions. X is an integrable function, cos x is also a integrable function. Now whenever we have product of two functions which are both are directly integrable functions, when both are directly integrable functions, then usually we'll use eyelet method to select first function. Now here x is a algebraic function, cos x is a trigonometric function. So algebraic and trigonometric, algebraic first function and trigonometric as second function. Okay, so we'll put x as first function and cos x as second function. Okay, then integration by parts. So what will get integral of x cos x dx equal to first function into integral of second function minus integral of derivative of first function into integral of second function dx. So x into integral of cos x dx minus integral of derivative of x into integral of cos x dx. Okay, now x into integral of cos x. Integral of cos x is what? Sin x minus integral of dx by dx is what? 1. Now integral of cos x is what? Sin x dx. Okay, so x sin x minus integral of sin x is minus cos x. So minus of minus plus cos x plus c. Okay. Next, suppose if you consider cos x as first function and x as second function, what happens? If you take cos x as first function and x as second function, then integral of x cos x dx equal to cos x into integral x dx, first function into integral of second function minus integral of derivative of first function into integral of second function. So cos x into integral of x dx minus integral of derivative of cos x into integral of x dx into dx. So cos x into integration of x is what? X square by 2 minus derivative of cos x is minus sin x, so minus of minus plus sin x into integral of x dx. Integral of x is what? X square by 2, so x square by 2 dx. So if you observe, after integrating, now here we have x, here what we have? X square by 2. Now here integral sin x into x square by 2. Now we are complicating the problem. We are complicating the integral because power of x is increased. So here x power is how much? 1. Here x power how much? 2. Okay. Now again we have to integrate. Again here we have product of two functions. If you consider this as first function, this as second function. Second function what we are doing? We are integrating second function. So integration of x square is what? X cube. So x power increases. So this is a never ending process. Okay. So to find integral of x cos x dx, algebraic as first function and trigonometric as second function. Okay, what will get? Integral of x cos x dx equal to first function into integral of second function minus integral of derivative of first function into integral of second function dx. So x into cos x integration sin x minus integral of dx by dx is 1 and integral of cos x is sin x. So integral sin x dx. So x sin x minus integral of sin x is minus cos x. So minus of minus plus cos x plus c. If you take in reverse order, that is cos x as first function and x as second function, this will be a never ending process. Okay. Next question. Find integral of log x dx. Here if you observe, only one function given. What it is? Log x. Okay. We don't know direct integration formula for log x. So it is not a directly integrable function, only one function given. In such case, only one function given and which is not a directly integrable function, in such case we will consider that given function as first function and 1 as the second function. Okay. We don't know integration of log x directly. So in such case, we will consider given function as first function and 1 as the second function. Okay. We take log x as first function and constant function 1 as the second function. So what will get? Integral of uv is equal to uv into first function into integral of second function minus integral of derivative of first function into integral of second function dx. So log x is first function and 1 is the second function. So integral of log x dx equal to log x into integral 1 dx minus integral of derivative of log x into integral of 1 dx. Okay. So log x into integration of dx is what? X. So x log x. So this part completed. X log x minus integral of derivative of log x is what? 1 by x into integral of 1 dx is x. So 1 by x into x, x get cancelled. So what we have? Integral dx. So x log x minus integral dx. So integral dx is x. So x log x minus x plus some integral constant. Okay. Log x integration of log x, because log x is not a directly integrable function. Okay. In such case, we will consider log x as first function and 1 constant number 1 as the second function. Okay. Now product of uv is equal to u into integral of v minus integral of derivative of u into integral of v. Okay, that is the formula. So integral of log x into 1 dx equal to log x into integral 1 dx minus integral of derivative of log x into integral of 1 dx into dx. Okay, log x as it is, integral of 1 dx is x. So x log x minus integral of derivative of log x is 1 by x into integral of dx is x. So 1 by x into x dx. So 1 by x, x cancel. So what we have, x log x minus integral of dx. So x log x minus integral of dx is x. So x log x minus x plus c. Okay. Next problem. Find integral of x into e power x dx. Find integral of x into e power x dx. Here if you observe, product of two functions, one is algebraic function, one is exponential function. We know integration of x. We also know integration of e power x. Both are directly integrable functions. So when both are directly integrable functions, to select first function and select second function, we'll use islet. Okay, so inverse, logarithmic, algebraic. So algebraic is first. So algebraic as first function and exponential as second function. Okay, take algebraic as first function, x as first function and e power x as second function. Okay, then integration by parts gives integral of x into e power x dx equal to first function into integral of second function minus integral of derivative of first function into integral of second function dx. So first function x into integral of e power x dx minus integral of derivative of first function, derivative of x dx by dx into integral of second function, integral of e power x dx into whole dx. So x into e power x integration is what? E power x. So x e power x minus integral of dx by dx is 1, integral of e power x is e power x. So integral of e power x dx. Now integration of e power x is what? E power x only. So final answer is x e power x minus e power x plus c. Okay, I will repeat once again. What is the given question? Find integral of x into e power x dx. X into e power x dx. Now here x as well as e power x both are directly integrable functions. So to select first function and second function, we will use islet. So according to islet, inverse, logarithmic, algebraic, trigonometric, exponential, algebraic first function, exponentially second function. Take x as first function and e power x as second function. So integral of x e power x dx equal to first function into integral of second function minus integral of derivative of first function into integral of second function. So x into integral of e power x dx minus integral of derivative of x with respect to x dx by dx into integral e power x dx whole dx. So x into e power x integration e power x minus integral of derivative of x with respect to x is 1 into integration of e power x is e power x. So this part is e power x dx. So e power x integration is e power x. So final answer is x into e power x minus e power x plus c. Okay, ma? We will conclude up to here. We will continue in the next session. Okay, remaining problems and next exercise will start in the next session. Okay.